Okay, here's video number 14 on the final review series. We're asked to be finding the absolute value of a complex number. Bad news about this is it's going to show you this is going to be the verbiage on the test. So you have to identify two things. First of all, absolute value bars, and then the I for a complex number. Okay, I'd like to illustrate that this is actually using the distance formula on a complex number plane. I've went ahead and plotted here -3 and -3i. It's this point right here. Remember, absolute value on the number line is distance from 0, but for a complex number, it's distance from the origin. So what we're trying to do is we're trying to find the length of this segment. Well, as you can see, I kind of drew us a little right triangle here, and we know if we have right triangles, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. Well, if I take the square root of both sides, this is what happens. So this is the distance formula. So all you have to do is pick out what a and b are. A and b are distances in this case. We're not going to worry about the negatives, or we're not going to worry about the imaginary number. This distance is 3, and this distance is 3. I guess to be technically correct, I could put this -3 squared plus -3 squared. But I know from experience it doesn't matter if the number is positive or negative. When you square it for both of these, it's going to become a positive number. So just keep that in your cross check. So this is going to be equal to -3 squared is 9, and again -3 squared is 9. This is equal to the square root of 18. Now I see on the test that there's none of those answer options on the test. So you have to use the rules of radicals to break this down a little bit. The rules of radicals are always we're looking for the biggest perfect square that goes into this number. In this case, it's 9 times 2. So I break this down into rad 9 times rad 2, and the square root of 9 is 3. And that's the answer. In this case, it was letter C.